Hi everyone, welcome to another episode on Learn on Cyber with T. Today I will take you through OWASP top 10 and we'll go through the first 5. I would try my best to summarize the explanation and make it as simple as possible. And then I would be looking into my screen for the most part. I won't be looking into the camera. Bear with me today and stay tuned. So we'll be going through all of the tasks on OWASP Top 10 2021, which is I think the latest, or we have another one for this year. I think we have for every 4 years or thereabouts. So if you don't know a lot about it, if you browse OWASP Top 10 vulnerabilities, you'll be able to see it is related to web application. So I'll be taking you through the task. We have 10 of them. I'll try my best for us to do the first 5 for today. So let's go through the class one step at a time. So now, what is the top 10 vulnerability that we have? We have broken access control. I'll be explaining each of this as we go through the classes. We have cryptographic failure. And for some of you that are familiar with cryptography, Ash and everything, I did a class on cryptography not long. Injection, this is something around command injection or SQL injection. Insecure design, in a DevOps, kind of life cycle or software development life cycle. You remember I said it's related to application security. So, a web app. So in software development lifecycle, one of the first things that happen is the design. When there is an insecure design that can give room for vulnerability, then that's where this insecure design comes in. Security misconfiguration also. Vulnerable and outdated components. When the components you have used to build your web app is outdated. You've not upgraded it or updated it and stuff like that. Identification failure. You know what identification, if you've been following my channel, you would have an idea what identification and authentication means. Software and data integrity failure. You know what integrity is? When your data is transferred from a client to a server or from one person to the other without modification. Security logging and monitoring failure. For everything that is happening on the system, there should be a log. There should be monitoring. When there is a failure, then you're not able to see into whatever a malicious person is performing on the system. Server side, request forgery. As I've explained in the past, that we have client side, we have server side. Normally, the server part of the web app shouldn't be exposed. When you have it exposed, then there can be a request into it that would put a malicious code into your application. So the room is designed for beginners with no previous security knowledge. So let's go through this one after the other. So we'll just say we have read through this part, so click complete. And now we can access the machine. One good thing about TryAcme platform is that you have a machine that you can use to work side by side while you're going through the learning. So we can start the machine here. And once we start the machine, we can then start the attack box. So that is done. As you can see, the machine is starting up. And we can click on complete, that we have completed that part also. Now, and keep it closed. So the first one, we said broken access control. What does broken access control really means? In simple terms, broken access control just means that someone who shouldn't have access to a particular data information have access to it because the access control is broken. I would repeat that again. An authorized user having access to something. I'd explained access control before in the past, where I mentioned that it should be based on least privilege, and it should be based on need to know and need to have. And what does that mean? It just means that an authorized person shouldn't have access to your data. Say your bank app, you are the only person that should have access to your bank application, know your balance and the rest. Someone else who is not the owner of the account shouldn't. But if from the bank's side, the access control is broken, then someone else will have access to your bank and they can take out your money. So that's what it means in simple terms. And as you can see, they mentioned an example here in 2019. It's very recent. How that an attacker had, the frame for a YouTube video marked as private. So if you're trying to upload a video into YouTube, and as you're uploading, you kept it as private. Normally, nobody should have access to it except you. And an attacker was able to have access to it. And a security researcher found this vulnerability. So as you can see, when an access control is broken, an unauthorized user would have access to it. So that's what broken access control means, and it's one of the first, it's the first top 10, OWASP top 10 vulnerability that is associated with web application. Now, let's go into Anton when it comes to broken access control. Now, they were trying to explain something here called insecure direct object reference. So direct object could be anything. It could be a user. They made the example here. So by objects, they mean it could be a file, it could be a user, it could be a bank account, it could be anything. And when the reference is insecure, then another person can have access to it. And they gave an example of, this website with ID of this. Let's say a customer owned this particular ID, And then because it's just once 6 times, you decide to try out 6 times, and you discover that you can also have access to the bank details of another person, which is different from Jason. This is Nick. So this is a typical example of broken access control. And we are going to try it out by ourselves. Let's click on that. We have read the IDOR. So in case you come across somebody asking you about IDOR, it means insecure direct object reference. And objects could be anything. It could be a user, it could be a bank account, it could be a file, it could be anything really. So they asked us to deploy a machine. To deploy the machine, we've already done that here. And they asked us to go to these IP domains. You already know how IP works. DNS, route, domains, back to IP. So this is like saying you're seeing a domain. So let's impute this. We can remove this actually. So they asked us to deploy the machine and go to this page. We are already on this page. They asked us to log in with this account and this password. So that's exactly what I am going to do. Test 1, 2, 3, 4. I hope it's working. Yes, it's quite slow. So let's try to log in. Not now. Now we are logged in into this account, and from the example they gave us, if you remember that we just decided to change someone ID here, and then we saw that we could access somebody's account. Now the same way, as you can see that this user have their ID as 1, so we can try our hands out and try to see, because here they don't need us to do anything, they just need us to log in. Then so we have completed this part, we have logged in. Now they said look at other users' notes. What is the flag? As you can see, this is a note that people are writing, things to buy from the store, carrots, potato, cheese, and lots of chocolates, right? Now from this place we can try to see other users and see what their notes is. And there's no pattern to this. You can try any number. You can try 15, you can try 20, but normally I would go to the next number. So as you can see, this person's notes, it's meeting with Sophie, lunch at Manny's. This is like somebody's itinerary or something like that. And also we can go to, we can try out 3 and see if we have access. This one, you're not supposed to see this note, which means you're on the right track. Well, we saw the note. Number 4, if we will try it out, as you can see somebody's New Year resolution in 2022, go to the gym for real. Write actual resolution for next year. So we could have access to people's notes that we shouldn't. We should normally just have access to this one, just this one, with ID of 1. Now, there's an int here at 5 that do note IDs start from 1, maybe go lower. Now, this int means that maybe we can try out 0, right? 0 is also a number, right? And we tried out 0, and here's the flag we are looking for. Look at others' notes. What is the flag? This is the only place that we have found a flag, and I'll try to copy the flag and put it here and submit and see if it's correct. And so it's correct. So what does this is just a way to show you how, you know, broken access control works. It works in a way that, you know, if a user could put in other people's ID and have access to their account, then something is broken with the application. Something is definitely broken, because normally you shouldn't see any other person's details or notes other than yours. So we have completed broken access control, and I hope you have learned something from this. And then we move to cryptographic failure. So what does cryptographic failure means? You know what cryptography means. You know, hashing, symmetric and asymmetric encryption. It's like encrypting data, file, your password, and what have you, so that you can protect it from unauthorized user. Like, you know, everything we do in cybersecurity is just protecting your data, protecting your files, protecting your life. Yes. And cybersecurity is also part of protecting human life. So, as you can see from the explanation, if you have access to this account, it would be nice to use it. It's a lot of words, so I would not explain all of those. But let's use, for example, you have an email account that you're using. You're communicating. So when you go to your Gmail, you're communicating with an email server to pull down your messages. That's what you see in your email account. You see you are the client, then you're communicating with an email server you're communicating with an email. So what you're seeing is the client, and what you are requesting information for is the server. So you're communicating with the email server. So in the tunnel of that communication, you expect that all your data is encrypted. Now, there are also email providers like Gmail, and when your email is just stored on their platform, you also expect that it's encrypted. And that's what we call, encrypting data at rest. When you are pulling your email from the server, which is between the client and the server, it means that you're encrypting, your data should be encrypted in transit. Now, this is all about cryptography, just to prevent man-in-the-middle attacks. By now, if you're following my videos, I expect you to know what man-in-the-middle attack is. So have we read this? I would click complete, just not to waste a lot of time. Now, we have supporting material for cryptographic failure. And basically, what the supporting material was trying to explain to us is about database, what we use database for. The common way to store large amount of data in a format easily accessible from many locations is usually in database. Database engine usually follow SQL syntax, and sometimes people use MySQL, PostgreSQL, MariaDB, and some other, database management system or something. DBMS or something like that. If I see it somewhere, I'll show you. So so because of that, the common and simplest format of a flat file database is usually SQLite database, and I would explain, this is usually installed with Linux, so we'll be using this at some point in the hands-on, in the practical aspects. So that's just what they are explaining here, how that you can use it on Linux, and you can use it to see what is in your database in case you have access to a database which normally you shouldn't have access to as an end user. You shouldn't. So that's what they have explained here, how you can use it to get all the information, including the hash of a password, which I'd also show you where you can crack the hash. So if hash is visible to you and you can easily crack it, then there's a problem, there's a cryptographic failure. And if you remember in one of my videos, I mentioned something like salting and peppering, where people had random numbers to the end of a password, just to make sure that even if you have a hold of the hash, you are still not able to get the plain text password. So, done with this part. I will quickly move to the second material, and this second material is where they are talking about an online tool, crackstation.net, which you can use to crack password hash. It's usually good at cracking weak password. When the password is strong, you might need other tools, other sophisticated tool. But like I mentioned SHA-256, SHA-512, and MD5 hashes. So MD5 hashes are the ones that are quite weak, and they are the ones where you have hash collision, where there is the tendency for hash collision. So this is how the crack station looks like. You just need to put the hash that you see, and then you'll be able to see what the plain text is, and we'll be using it in one of our questions. So yes, we already know what we are supposed to do. Now this is the challenge. Now it's time to put what we have learned into practice. For this challenge, connect to the web app. So I will just copy this and then try to connect to it. And we have a web application, right? And let's use it to answer our question. So the first question is, have a look around the web app. The developer have left themselves a note indicating that there is a sensitive data in a specific directory. So we can just look around. There's not much happening here. We have this, we have nothing more. But if we want to see what the developer has left, we are going to be looking into the source code. So let's take a look. So let's take a look, view the page source code. So as you can see from the source code, it doesn't look like there is a note, because when there is a note, you will know. They always, there's a sign that you have a note in your code because it's marked out as a comment. So from this one, it doesn't look like there is a note actually, but we also saw something like login. Maybe we can check that one. So here is the login page. You can also view the source code here, and yes, we have a note. As you see, they comment out the note. So the developer forgot to remove a particular sensitive directory. So let's look for it. As you can see from the notes, the sign for the beginning of the directory is this // So now we have /assets. Now I'm guessing this is the directory we are looking for, but let's try to put it here and see if that is true. So basically it's true. Now they said navigate to that directory and you will find in question 1 what files stand out likely to contain sensitive data. Now we have the assets, right? Let's go back to the home page. There it is, and then put /assets. So with /assets, we could, normally you shouldn't have access, and then we could see that there is a database here, and most likely databases are the one with the sensitive information like your username and your password and stuff like that. But let's copy it first and then input it here and see if that's what we are looking for. Yes, exactly, that's what we are looking for. Now, using the supporting material to access the sensitive data, what is the password hash for the admin user? Now, remember, these are the two supporting materials we have. We have one talking about SQLite, and then we have the second one talking about the crack station. Don't forget. So let's go back to the challenge. It says use the supporting material. What is password? So now that we know that the password will be present in the database, we can click on it you downloaded the file for the database. But remember that we have to go into our terminal to be able to use that SQLite, which is here. So we have downloaded the file, but let's check if we have the I want to make sure you can see the terminal. So let's check if we can see what we have downloaded. And this is just a command to list everything that you have in the root. So as you can see, you have this file that we just downloaded there. Now, according to the explanation here, we need to, first of all, if we do file and this database, let's see. That's the first thing to do. So if we do file and the database, which is webapp.db, we'll be able to see, some details about it. It is an SQLite database and all of that. So when we see that, it's easy for us to use this SQLite 3 just to pull the information in the database. So if we paste it in and then we do again the database, be able to pull the information in. Now we already pulled the information in. It's asking us what do we need. So it's like you use a server to pull an information from a file, and it's asking you, okay, so what more information do you need from me? Now we can decide, because, okay, I would slow down for a little bit. Now from this part of, and I would open what we have downloaded here. We have downloaded it here. Let me open it so that we can see what is inside. Now, from this, I'll pull it down a little bit. From this database, you can see that the database have two tables. We have table for session and we have table for users. And as you can see, the admin that was asked from us is in the table for users. Now, we can go back once again. And I will try to close this one because we don't really need it anymore. I'll try to close it, and I would also go back to the terminal. Now, what do we need? We can pragma the table information. We can pragma what is in the table. As you can see that we already know the table where the admin belongs to. So, and the name of the table is called users. So we can pragma what is in users to see what is there. And as you can see, you see the first column contains user ID, the second one contains the username, the third one contains the password, and the fourth one, I think maybe admin something, not sure what this last one means. Now that we have seen what every column in that table means, we can also try to select everything from that so that we can see, if we can see the password hash for the admin. Remember, the name of the table is called users, not customer. The customer is just an example. So, but the table we observe from the database, if you remember, is called users. So let's try to see what is inside. And as observed, as you can see, that we have user ID. This is user ID. We have the username. We have the password. And okay, I think this last one is admin integer. So is this person an admin 1? Is this person an admin 1? Is this person an admin 0? It means Alice is not an admin, Bob is an admin, of course admin is an admin. Now from here we can tell that this is the admin password hash, and we are going to quickly copy that. I will close this supporting material up. And then they ask us, use the supporting material to what is the password hash of the admin user? And I will paste it here. That's exactly what they asked for. They said, crack the hash. What is the admin plain text password? Like I initially told you, I told you that the page that you can use to crack up these weak passwords, as you can remember that they said they are usually like with MD5 hash, is crackstation.net. You can access it, it's free. We can try to paste the hash there at last. Then we can crack. So here is the cracked version of the password. And this is the results. That means this is the plain text password for the admin. And then we copy, paste it here, and then submit. Yes. And then we were asked to actually log in as the admin. Don't forget, we need to log in, we need to go back to that, to the original place, which is here. Yes. Admin, login. Now we have our flag, and this is our flag. So now we can click on submit, and I hope it works. So we have done cryptographic failure challenge. So what is the next one? Injection. I would stop at this point, and this is because I'm looking at the time and I've already used 28 minutes to explain just 1 to 8 tasks. I don't want the video to be too long. I would stop and then we continue for the next episode. So see you next time. Bye.